My name is Maximiliano, right? Long name, Max is okay. And this is going to be hacking web performance. I'm Firt on Twitter, F-I-R-T. Let's start quickly saying that I'm a mobile web developer. I have been doing web development since that browser, okay? And I can say today here, I can admit here today in ForwardJS that I have even used front page, right? Have you ever used front page before? No? I'm the only old web developer here? Okay, we have a couple, yeah, come on. I'm a frequent traveler, so I'm from Argentina, but I'm doing trainings and conferences all over the world, 55 countries so far. I have authored some books. Okay, the last one is High Performance Mobile Web, but we are going to cover some of the stuff from that book today. So I have two goals for today's talk. The first goal is I want you to learn new tricks. If you can, see if after 40 minutes you can learn at least, I don't know, 3 new tricks, okay, I'm good. And my second goal is that I want you to feel bad, right? About probably what you're doing, you have done, fortunately what you're going to do, right? So you need to feel bad about this. So let's start talking about hacking web performance. So I know you know several things. So I'm not going to spend too much time on things that you already know, right? But your users right now are sad. You are probably losing money. And the reason for that is because your website is slow. I know you know that. And just some data that you already know. Okay, so just a half a second delay will increase your user's frustration. Also, it will reduce your traffic. Also, it will reduce your sales. That means money, okay? Also, you probably know this, but basically, for a human being to recognize something as being immediate, it has to happen within 100 milliseconds. Okay, so the feedback should appear within 100 milliseconds. Also, you know that we have something called what's happening with the flow of thoughts. When you're expecting something, and that something is taking longer than 1 second, okay? So your brain starts to think on something different. Okay, so, oh, how bored is this talk, or I want lunch, or wherever, right? So, and on your website, that means that you are probably losing users. Okay, so I know it feels weird to talk about just 1 second, but that's true. It was measured, okay, on the brain, so that's happening to us all the time. When we are waiting for something and that something is not appearing within 1 second, we have a problem. But you know that, right? And probably you also know about RAID. It's just one approach. It's not the only approach, but it's one approach to specify goals when we are talking about web performance. It's coming from the Chrome team, from the Google Chrome team. So because sometimes it's difficult to measure how fast is fast. Sometimes you say, well, my website is fast. Okay, but how fast? So it's a way to specify some goals to our website. RAIL means response, and means that everything that happens within your website should respond within 100 milliseconds, like a tap, right, or a click, or when the user is starting a scroll operation, that scroll should start within 100 milliseconds, and you can measure that. The A is for animation, and roughly that means that your frame rate should be 60 frames per second, okay? Just for the user to be happy and for you not to be losing money. Then idle means that everything that you are doing, mostly in JavaScript, while the website is being idle, should not take longer than 50 milliseconds, okay? The last one, and you know this, and I'm pretty sure that you are achieving this, you need to load the page within 1 second. Okay, so that's the RAIL approach to define our goals for web performance. So you need to load the page within 1 second, because if you are not doing that, you are losing people, you are losing users, okay? But you know that. So 1 second is our budget, okay? So that's our budget, so we need to start measuring what's happening in the network layer, what's happening in the browser when the user is loading our website to see if we are within that budget, okay? Cool. But you already knew this. So performance is really important. We need a great speed index. And by the way, I know you know what a speed index is, right? So I'm not going to explain that, but it's a new metric that you need to understand that basically verifies how fast your website is being rendered. Because you know that the page load is not really so important right now. So the onload event is not really important. We have other metrics, such as a speed index, that will give you more idea about the perception of how your website is being loaded, right? Is it slow or fast? And we have a budget of 1 second, okay? So we all know this. And because we all know this, or you know this, you are already doing a lot of stuff, right? For example, you're already optimizing the network. For example, enabling gzip on your server, verifying that you have enabled gzip, keep alive, and many other tricks server-side. You're also already using CSS as an appetizer. So when you're going to a new restaurant, yeah, you're picking an appetizer, but it should be small, okay? It's the first thing you're going to get as soon as possible, because if you don't do that, basically the browser will block rendering. The browser will not render any pixel on the screen if it doesn't have the CSS and it didn't parse that CSS. So you need the CSS as small as possible and as soon as possible, okay? As an appetizer. You're already doing that. Also, JavaScript is a dessert. Kind of sweetie, right? But at the end, after the main meal, that means you need to defer every JavaScript that you have, because JavaScript is blocking, in this case, parsing. So basically, it's blocking the browser to continue parsing the HTML. And we have a tiny budget here. Even sometimes, if we don't get a dessert, it's not a big problem. At least the first time you're getting into that restaurant, okay? So the same happens with JavaScript. So JavaScript should always be at the end. But there are different techniques to do that. I'm pretty sure that you're already applying right now. Also, I'm pretty sure that you're optimizing your images, right? That if I'm going to your website and I'm applying like OptiPNG or any other tool available, I won't get any optimization because you're already optimizing your images, right? Cool. So also you have an HTTP cache policy, meaning that you don't have cache as your enemy, you have cache as your friend. So that means that all your assets are currently cached in your user's browser, okay? Probably with a far expiration date when we are talking about static assets. So I know that you're already doing that. And you're probably using service workers, right? You are not part of the 99% of the web that right now are not using service worker. You are part of the 1%, right? Because you should be applying service worker to increase performance for the next visit of your user, even of that same visit when it's changing to another HTML. You can basically serve some of your static assets immediately. Okay, you're already doing that, I know. And you're also reducing your redirects as much as possible, so you don't have any redirects. So if the user is accessing your website, you are not like some airlines. I'm not going to say that, for example, American Airlines is doing that. That when you go to aa.com, they send you to www.aa.com, and then they send you to www/homepage, and then they say, oh, it's a /homepage/default, and then they say, oh, but you're an iPhone, right? If you're an iPhone and Android, you need to go to mobile.aa.com, and the process starts again, and you got around 6 redirects to get to the homepage and see when you're in roaming in an airport, okay, in the other part of the world, the gate of your flight. You are not doing that, right? And you already know that each redirect that you are doing can take up to 1 second between DNS request, the DNS query, then the TCP connection that needs to be started to that server, the HTTP request with all the headers, then the HTTP response just to realize that it's not here, it's there, okay? So you're not doing this. Also, you're already working with TLS and HTTP too, right? Of course. Everybody's doing this, okay? So you know that. Because, not just because of security, but because you also can apply now new techniques that are available on the web and new compression algorithms that work only on TLS. There is an explanation of why. Doesn't matter right now, but you should be there. And you need to use HTTP too because it has header compression. So you are probably avoiding around 1K per request. So you are reducing 1K per request that right now you have on HTTP 1.1 per request. But I'm pretty sure you are not doing so many requests, right, per page, like probably 3, 4 only, okay? In between CSS, JavaScript, images, web fonts, videos, and many other things. Probably 2 or 3, that's the normal. So you're doing this, okay? You know, I'm watching you. But that's not what I want to talk today, okay? So that's basically everything that you already know and you're already doing. So what's the problem then? Well, yesterday, so I have updated these slides yesterday, Google released a new research, so you can go think with google.com and read the full report. On a mobile landing page, the average time to load that is 22 seconds. 22, okay? If the page takes more than 3 seconds, 53% of people are leaving that page, okay? So we have a big problem, even if you're doing everything that we have already covered so far, okay? So we have a big problem. So that's also data coming from that report. So you can see there, when you have a page load that is taking more than 10 seconds, your probability of bounce is increasing by 123%, okay? So you are losing users, you are losing money. So that's a problem. It's a very big problem. Because we do have this problem, we have been seeing things like AMP or Facebook instant articles. How many of you are happy with AMP? Let's see. No one? I guess that you know what it is, right, at least? Yeah. So accelerated mobile pages. That is coming, it's an open new spec or protocol, let's say protocol for now, to use HTML5 web components. It's a subset of HTML5. It won't let you do what you're doing right now, so it won't let you use even IMGs. So you need to use an AMP IMG tag. So it's a couple of components that you can use to maximize the performance on mobile devices, because we do have a problem, okay? So that's why we have AMP. And AMP is like, it looks like very restricted. It's really working with our freedom on the web. So there are a lot of controversial things around AMP. But why AMP is existing right now? Because we do have a problem. And sometimes we are not accepting that problem, okay? The same happens with Facebook instant articles that are basically running inside Facebook, but when you are clicking on a media post, usually it's a Facebook instant article that's not really being rendered on a browser or even on a web view. So, and also, we have been always underestimating mobile web. Okay, so I have been working with the mobile web since WML. Have you ever played with WML? No? Lucky you. We also had some WML script at the time, by the way. So I'm talking about just text-only browsers, right? 3 lines of text and 2G connections. So, but since that time, I have always seen problems of underestimation mobile. Okay, so now we say, oh, so mobile is simple, right? You just need to reduce the screen of your Chrome, and that's all. If it's, I mean, if responsive design is taking care of laying out like a good UI, it's enough. Well, it's not. And also, I know that some people think that, yeah, mobile is iOS and Android. Yeah, I'm not going to talk about BlackBerry here, okay? But it's iOS and Android, that's true. But when we're talking about the web, we are not talking about the operating system, but browsers. And probably you're thinking, well, that's Safari and Chrome. It's simple. Well, it's not. Do you know, for example, this is also coming from a recent report, that today on iOS, more than half of the web browsing is being done inside Facebook, not inside the browser, right? So when you click on a Facebook post and it has a link, it's not being opened by default, unless you change a preference that nobody's changing, at least real people, not us. You're seeing that inside Facebook. You can say, well, this is Safari. Well, kind of. It's a web view, and there are different web views on iOS. It depends on the version of iOS, it depends on the version of Facebook, which version of the web view you are using. And even if it's the latest web view, it might not have the same performance and the same features than Safari on that same device. And the same happens on Android. 34% of the browsing is happening also in Facebook. And it's not just for Facebook. You can see that there is another 4% there, the gray part. That's Twitter and many other apps there. Yelp, right? When you click on Yelp, you are looking for a restaurant, you click on the link for the menu that is being loaded inside the web view and in the browser. Okay? Have you ever tried your website inside the Facebook web view? Because half of your users, 40% of your users, are browsing your website there. So did you test performance there? Did you check if your APIs or everything that you are doing are working properly there? Well, you should. Also, it's not on Android, for example, it's not just Google Chrome. So today, around 20% of the web browsing in Android is happening with these browsers. And I'm not sure if all of you can recognize even the icons, right? So the first one is the Samsung Internet Browser that is growing each month in terms of market share. Is the browser is coming now like by default, more highlighted in Galaxy devices. The UC browser, it's a browser from China, but it's also available on the rest of the Asian market. For example, in USA, I think it's around 3% of the web browsing on mobile devices is being done by UC browser, 3%. Okay? Opera Mini, and the last one is the very old and terrible in terms of performance Android browser. Okay, it's still there. So right now it's around 4% of people are still browsing the web with that old WebKit-based, and it's an old WebKit, by the way, Android browser. Okay, so when you think that this is just Chrome and iOS, it's because you're underestimating mobile web. And also, none of us are average users. We usually have the latest phone with the best possible data plan, and that's not an average user. The average users out there probably has a cheap, kind of 1.5 years old Android phone, and probably not even in 4G. And now it's time to talk about cellular networks. And remember, most mobile devices are on cellular network. Yeah, you can be on Wi-Fi, but you can be on the Wi-Fi from this hotel, for example. Right? So, but let's talk about cellular networks only, not about hotels' Wi-Fis. Maybe you're thinking, hey, we have 4G, we don't need to worry about performance anymore, and 5G is coming. Well, let me tell you this. Only 21% of people worldwide is in 4G right now. Okay, only 21. Also, so if you pay attention there, the red part is 4G. The black part is 3G, and the other one, the silver one, the light gray one, is 2G. So today, around 45% of people worldwide is browsing the web in 2G. You can say, even if it's not happening to you, it happens even here. Okay, I don't live here, but I'm here a lot. It's like my second home, San Francisco, the Bay Area. And sometimes I'm on 3G here with the latest iPhone. And sometimes I can drive north, like to Sebastopol, like 1 year and a half, 1 hour, not a year. 1 hour and a half driving north, and I was in 2G there, okay, on some parts. So you can also get 3G and 2G. And even if you're a lucky 4G device user with a 4G plan, so I already said that, 30% of the time 4G is not being used because you are being downgraded to 3G and 4G. Okay, 3G and 2G. So even if you are in 4G, okay, the problem is the latency. Even on 4G, so there you see minimums and maximums in terms of seconds or milliseconds on latency. The latency is the round trip time. So the time that it takes the data to arrive, and it's not the data time, it's not the download time, okay? So if you look at 4G and home, that's the last two things that you see there. So 4G can have around 250 milliseconds of delay, okay, of latency. That it's much bigger than a wire connection that you have at home. So even on 4G, that not everyone is there, okay, we have latency. So that's really important. That's why we have these problems on mobile devices. So testing or measuring on your desktop with basically a mobile viewport is not enough, okay, to understand how the mobile web works. So Now that you know the problem, let's start talking about, okay, what we can do. Let's hack web performance. So you already know everything that you have done, right? I'm watching you. You already did that, everything that we have covered so far. But what else can we do to achieve our goals? Well, first I will here give you some quick tips on, okay, what can we do to even hack the first load further? So you need to avoid more than one round trip to the server for the first load. Because remember, we have a budget of 1 second. If on 4G we can have up to 200 milliseconds of latency, okay, we still have just how many? 600 milliseconds, 500, because the server also needs time to give me the response, okay? Even on 4G, I'm talking about 4G, not even 3G. So we need to avoid more than one round trip for the first load at least. Sometimes, remember that I mentioned before that sometimes the page load time is not really important, so the onload JavaScript event is not really important. What is important is the perception of the page being loaded from a user's point of view. So because we don't want the user to start thinking on something else. Remember the 1 second trick? So to do that, we need to try to deliver the ATF content in 14K. The ATF content is everything that the user is seeing in the mobile phone in the first scroll without the rest. Okay, so that's the above default content. So why 14K? Because if it's roughly 14, it's 14.6K. If we use 20K, there is a very good chance, very good probability that we will need 2 round trips for that because it will arrive in 2 TCP packets, the response. So probably we won't fit the first load, the first page on a 3G connection within 1 second. So if you are feeling really scary right now with the number, you need to remember that you're using gzip. Okay, so it's 14K gzipped. So that means that it's around 70K of HTML, CSS, and JavaScript. Everything embedded in that same request. So just go to google.com with a mobile user agent and look at the source code. They have already embedded the CSS and the JavaScript on the HTML, so it's not an external file, for mobile devices at least, okay? Just to achieve this 1 second issue. So if you still have a space, okay, you can even embed your logo or low resolution images, right? Very low resolution image, right? And then you are going to replace that with a better version. But at least on the first load, within 1 second, the user will see your ATF content. You can also announce DNS queries as soon as possible. So there is a new link that you can use at the top of your HTML to explain to the browser that you're going to use another DNS for a resource, for analytics, for tracking, for ads, for wherever. And then you can save like valuable couple of milliseconds at the top, because now we know that each millisecond counts here, because we have just 1,000. And we are not in charge of all the latency of cellular networks, okay? So you should avoid HTTP to HTTPS redirect. So now we know that we need to be on HTTPS, right, on TLS. But the user is not typing HTTPS : / blah, blah, blah. So by default, the browser is trying HTTP, and then you are going to make a redirect to the HTTPS. Well, you can avoid that using HSTS. That's a new protocol that is available on most browsers, even AE, right? Even AE. And you can send a header to the browser on your first redirect. There will be one redirect, and it will have a max age, and that means the browser will cache for the next time that you want HTTPS always, okay? And also you can go and opt in on hstspreload.org, and where you can opt in for TLS always. And most of the browsers today are using that as a whitelist. That means that if your website is there, when the user is typing your URL, it will go directly to HTTPS, okay? So you will avoid up to 1 second. Remember, on 2G connections, a redirect might take 1 second because of the latency and the DNS query and all these problems that we have. So now let's talk about the data transfer. Because, okay, probably the first law is there, but how can we do something more about the data transfer, because we know it's going through cellular networks now. At least on mobile devices, that is right now more than half of the visits that you might have on your website. You can use Zopfli. So Zopfli is a new compression encoding algorithm for gzip and deflate. So that means that you can, the same HTML, the same CSS, the same JavaScript that you have can be compressed in the same gzip format, okay, saving more bytes. And that means less time on the network. So you can save from 4 to 8% of data transfer. And because it's using gzip, it works everywhere on every browser. What's the catch here? Well, it's 80 times slower. But it's slower, I mean, the coding process, the encoding process. So that's server time, that's CPU time on your server. Yeah, it's more, but you can pre-compress this, mostly on static assets, and the advantage is pretty cool. Mostly when we know that we have a tiny budget. And then we have another one that is even better. It's called Brotli. So Brotli is a new compression format directly, so it's not gzip compatible, okay? And so both Zopfli and Brotli are open. They're coming from teams at Google, but they're open. And they are, Brotli now, it's available on Chrome, but it's also on Firefox, okay? And it's coming on Edge, and it seems as it will be in Safari as well. And it's optional, of course, so you need, in this case, you can say up to 14%, but by the way, it depends on how you are also zipping your content right now, because the zip also has like several values that you can check from 1 to 9, so how compressed do you want the file. So the final percentage, the final saving depends on that. My average, it can be around 14%. Okay, and you need to check the encoding header server side to verify if the browser is supporting Brotli or not. Brotli works only on TLS. So also you can create a low resolution version of your whole website. So why is that? Because sometimes we know that sometimes the user is in a good connection, it's in 4G, okay, or in a good Wi-Fi, and then we can serve like something really nice for the first ATF content within 1 second. But sometimes that's not the case. So we can check there is a new client hint header called save data that browsers are starting to implement. That means that if the browser thinks that the connection is not good enough for any reason, I know it can be in roaming, in 2G, it will send you that client hint header, save data. So then you, server side, you can send like a very low resolution version of images, even if it's the latest Galaxy S8. Okay. Also, you can use the network information API. It's available on mobile only. You can use it even inside a service worker. You can detect if the user is in 2G, 3G, 4G client side. And performance timing API, it's also available even in service workers, and it will let you calculate, okay, how good is the connection right now on the fly, okay, and make decisions about that so you can offer the user the best possible experience at that time, okay? So that will let you measure bandwidth, basically. Also, talking about images, so I know that some of you are having like different versions of the image. This is a report coming from Ciencia Mobile. So basically, if you have like 3 versions of the image, let's say roughly, like desktop, tablets, and phones, you are saving data. That's the gray in the middle, okay? But if you create one file per device or per context, you can save even more. That means multiple versions. How many versions? Near to infinite, probably. So, but the advantage is that we are going to save a lot of bytes, and the content will be available faster on users' screens. So you need to embrace responsive images here. Okay, don't create just 2 or 3 versions, and you know, well, all the phones will have like the 4th version, right? Because we are going to send pixels that will never be rendered there, and there is no, we don't have budget for that, remember. We have a tiny budget, so we don't want this. So not create just 3 versions, okay? So we can make it better because today, 65% of the traffic is because of images. So we can really improve a lot okay, creating end versions dynamically. Talking about images, okay, what we can do with images right now? Well, we know that the picture is worth 1,000 words. Like, for example, in this case, our users that we know that are sad, but that picture should load for that, okay? And that's another issue that we need to think about that. So it's time to replace JPEG and PNG. And we can do it, okay? So I took this picture in New York, okay, a couple of months ago. So I used that as an example of how can we save data without changing compression or without losing quality, okay? And you have WebP, okay? With WebP, we can save 35% of the bytes. The problem with WebP is Chrome, Opera, and Samsung Internet only. On JPEG 2000, that's Safari only. I don't know if you even know that we have a format with that name. You can save 19%. JPEG XR on Edge only, 39. Okay, and this is really cool because remember Zopfli, that new compression algorithm for gzip and deflate? We can use that with PNGs as well, and that's available everywhere. And you can save around 20%, at least in my case, with my picture, compared to a normal PNG that is already optimized. Okay, of course, it's taking 80 more times to compress that PNG, but it's worth the time because now we have less transfer for that image. And probably you're thinking, well, but we need to deal with different browsers and this compatibility. Well, we have picture now, okay? And with picture, you can specify different types, and the browser will pick the first one that is compatible with that browser. Yeah, you need to encode your images server-side in different formats. Yeah, that's the catch here, okay? But remember, our priority is performance, is delivering the content to the user within 1 second. That's our only goal here. And also you can use HTTP client hints. That is something that you can opt in, like with a meta tag, and then the browser will send you hints about what's happening client side to reduce basic complexity. Because if not, you need like too many sources inside the picture. Because it's not just about the format, but also about the current, when you're using responsive images, it's not about the format only, but also about the current context, such as the screen width. Okay, so you can use client hints to reduce that part. Also, this is really cool. You can start decoding images in the background. Because the image, so when the bytes of the image have arrived from the server, then the browser needs to decode that, and it's doing that in the main thread. And that's basically blocking other things to be happening. So there is also like an experiment from the Google Chrome team of thread images. It's basically a web worker that is going to decode the image for you. Okay, so it's pretty cool in the background while the browser is still doing something else. Also, you should stop using animated GIFs, right? And not because of the animated GIF itself, okay, but the format. Okay, that format is really old, so it's really inefficient. Right now, you can replace that with animated PNGs. Yeah, that thing exists. It works on Firefox, on Safari. And animated WebP is also another format that you can use. Or you can use videos. The problem with using videos for animations is that usually on mobile devices, videos were going full screen. So it's not really a small animated GIF. Well, now you can use mute videos, so videos without an audio part, or you can use a video with a mute Boolean attribute. And on iOS, you need to add also another attribute called WebKit plays inline. And then you can use the video. The user will not see any control for the video, and it will be animated inline, not in a full screen video player. Okay? So, and that will be faster for animations. You can also use a lot of tricks that are available out there for preview images and make the illusion of loading images really fast. I'm pretty sure you have seen, for example, this on Medium. Okay, on Medium, sometimes you see an image like that, and that's basically just a couple of bytes that will generate that really quick video. It generates the impression of being really fast. Also, Facebook is doing this, and Facebook is downloading a very, very, very small image. And very small means 300 bytes. Okay, so every picture is being converted into 300 bytes. There are even removing the headers of the JPEG, right? They're doing really cool stuff there. And they are using blur and scale filters, and that's the preview that you see really quickly, right? Immediately. It can be even embedded in the HTML using base64. It's just 300 bytes. And then you are going, after the user is seeing that, so it perceives that it was loaded, we replace that with a high resolution image. So, and also the future looks interesting, because we will have new formats as BPG and FLIF. If you know about them, you can Google that, okay? Then the last part that I have here is, okay, how can we have the limits that we have on the browser today, thanks to service workers? So this is a couple of ideas to try to blow your mind a little bit. So what if we can make a CDN race for performance? So we are loading images or scripts or CSS, and we have different CDNs. So we can make them race with service workers, okay? And then the faster one is the one that we're going to use from that time on in that load. That's possible today with service workers. Also, you can create delta updates. Let's say you have in the cache your CSS file, and you create the protocol to recognize what part of the CSS have changed. You can just deliver the changes to the client, and then the service worker will split everything or will merge the cached version with the new version, and you will see from your side, from the browser side, you will see just the final CSS file. Also, you can use streams. For example, for APIs, if you're sending data from a web service in JSON, why can't you just parse the data when it's coming? Right now, you're waiting for the full JSON to be available. Well, with the streams, you can parse parts of the JSON. Okay, that's an API inside service workers. Your own compression method, just squeeze your brain, right? Because now service workers can do a lot of work in the background and deliver something compatible to the browser, even if the browser is not supporting your own format. For example, you can also use this for progressive images. Why can't we send a thumbnail of an image, and then instead of replacing that thumbnail with a high resolution image, we are going to just download the rest of the bytes that we need to complete the high resolution version. Remember I mentioned BPG? That's a new format that's even better than Zopfli PNG. You can try it today. There is an open source service worker there that has a fallback to PNG that will let you, it's a BPG encoder in a service worker. So it will take a BPG file that is smaller than the PNG. It will convert it to a PNG on the fly client side for the browser. Okay, so just ideas that you can use to hack performance. So, feeling bad enough right now? Yeah, is enough? Yeah. So, performance is a top priority, okay? You need to always try to push it even more, always even more, okay? It's a worthwhile effort. So please try to stop, your users right now are like this, right? They're basically praying for your website to be fast, so make it fast, okay? Thank you.